Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. So how many tricks have you learnt on the channel? I hope it must be 100 plus or maybe 200 plus, and you must be really getting benefit out of these tricks. Let me tell you one good thing about tricks is you save a lot of time, right? But one thing which you have to be careful about is that you need to practice these tricks. Here is one more trick which I am going to take up in this particular video, and you will realize that mathematics is really wonderful. If you think smartly about the numbers, numbers are going to befriend you also, and they are not going to trouble you in terms of calculations. So if you can perceive numbers in mind, and if you can think about the numbers correctly in the mind, then the numbers are not going to be difficult. Look at the numbers which I have written here: 287296101124, all 6-digit perfect square numbers. 6-digit perfect square numbers. I can't find the square root of these numbers using what? The prime factorization? Are you joking? We can't do prime factorization of such huge numbers, right? And you should not even try that. The long division method, yes, it works for us, the long division method. But if we can make the long division method little bit compact by little variation, it will be amazing, right? And let's not complicate things. Let's simplify things for ourselves, for our students, for the mathematics teachers, so that they can also transmit the knowledge. So subscribe the channel right now, friends. Come on, if you're watching this video, you got to click the subscribe button and share the link with your friends. That is important. Let's spread the knowledge. Let's spread good important tricks which can help each and every student. Okay, so click the bell shaped icon and you will get all the notifications on the channel. Was the entire video. This is going to be an amazing video. So the first thing I am going to do is to find the square root of 101124, a big 6-digit number, and let's see if we can have a short trick. I'll take like 3-4 minutes explaining it to you, okay? But in the second question, I'll take maybe 1-1.5 minutes, and in the next slide, when I move on to big numbers, more big numbers, I may be taking maybe 30 to 40 seconds. How many students have you seen who can find the square root of such big 6-digit perfect squares in 30 seconds? I think your answer should be, I have never seen somebody like that, right? So you want to be one among those persons, who can actually do this in 30 seconds. So watch. Now, the square root of this number 101124, if I make pairs from the right hand side, I get 3 pairs, and so my answer is going to be a 3-digit number. Now what is that 3-digit number? So this, or this. Whenever I find square root, I always get 2 possibilities. See how? The 24 here ends in 4, and there is 2 whose square ends in 4, because 2 square is 4. And likewise, I can have 8 also, because 8 square is 64, again which ends in 4. So you will always have 2 possibilities for the unit digit of your answer. Okay. Yeah, obviously, if you have a 0 here, then it will end in 0. If you have a 5 here, then it will end in 5 only. But nobody is going to be that liberal with you and give you such questions in the exam. They will only give you questions which require more thinking, right? So 2 square is 4 and 8 square is 64. So I wrote 2 and 8 here. Now job done for this 24. Leave it. Now come to the first one, 10. This number 10 is greater than which square? It is 3 square, right? 3 square is 9, and 9 is just below 10. So I need to find a single digit whose square is very close to 10, but it should not exceed 10. It should either be equal to this or less than this. So 3 square, and this 3 forms the first digit of your answer. So I have 300 something here and 300 something here, ending in 2 and ending in 8. Now come to the middle digit. For that, obviously I have to consider this 11. Now watch the important step, the most important step. This 3 square, right? Here we have 10. 10 minus 3 square, 9. 10 minus 9 is 1. So I will write a 1 here. And then the second doublet, 11. I need this number. 10, the first doublet minus this square. 10 minus 9 is 1. And the second doublet with it makes it triple 1. And after that, I just need to write what? The number here was 3, right? Double of 3 is 6. So I will write the double of this number here, 6. And now the long division method works for us. And let's not take pressure by thinking that we are doing long division method, because most of the students who do square roots, they get troubled when they even hear long division method. And that's a bitter truth. 7 out of 10 students don't know how to use long division method. Okay, so I'll not use that word. The method is, I need to get to very close to 111. So if I choose 1 here, it becomes 61. So I have to multiply it by 1 only. Now 61 times 1 will get me close to 111. But if I do 62 times 2, see, 6 is fixed. Now we have to just change this number. So 62 times 2, this will be 124. This will exceed 111. I don't want to do that. I want to stay below 111. And so 1 is the digit which I want. And this 1 forms the middle digit of your answer. With little practice, you will understand this and you will do this in 5 to 7 seconds, this part. Okay, so 312 or 318, that will give me my answer. Either of these two is the square root of 101124. Now how do you find which one is the square? Now for that, we have two different methods, both from Vedic maths. One, the digit sum method, and the second one is the vertically and crosswise method of multiplication. See, here if you count, add all the digits of the question, 4, 5, 6, 7, 8, 9. So you get a digit sum of 9. So 1, 0, 1, 1, 2, 4 has a digit sum of 9. Okay. Now let's check 312. 312 square. What is the digit sum of 312? It is 6, right? 3 plus 1 plus 2 is 6. So 6 square. And 6 square is 36. And what is the digit sum of 36? 6 plus 3, 9. So that gives me a hint that 312 should be the correct answer, because I got the same digit sum. Now let's check whether this is okay or not. 318 square. So 8, 9, 10, 11, 12. 12, right? I can cancel 8 plus 1, 9. In digit sum, this is the beautiful thing. You can actually cancel the 9s. So you have only 3 square, which gives you 9 again. Now this is why I took up this question first, because in so many questions of square roots of 6-digit numbers, the teachers on YouTube are going to tell you to use the digit sum method and get to the correct answer. But this can happen in the digit sum method. You will get the same single digit, and in such cases you need to be applying the vertically and crosswise. How do we do that? We have to find the intermediate number. 312, 318. What is the number in the middle? It is 315, right? Now I will find the square of 315 using Vedic maths. Why am I doing this? Because I got the same digit sum. Had I got a different digit sum here, this would have been my answer, and the digit sum which tallies with this digit sum is the answer. But in this case, all the digit sums are same. So I have to do the square of the intermediate number, the middle number. For this, square of the number ending in 5 is ending in 25, and then the remaining number 31 is to be multiplied by the next number 32. Now this is Vedic maths. 2 ones are 2, 6 plus 3 9, and 3 3s are 9. So 9, 9, 2, 2, 5. That is the square of 315. How much time we are going to take to do this? I think again 4 to 5 seconds, right? So 99225 and my number 101124 is greater than this, right? This is greater, and so the greater one is the square root of 101124, and that completes my problem. Why didn't the digit sum method work? Because all the 3 digit sums were same. Okay, if you have understood even 50% of this, it is fine. Let's apply it here and we will check whether we get the correct answer or not. Okay, so square root of this means 3 pairs, so 3 digits. So you will have dash 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 or dash dash dash. The last pair ends in 6. 4 square is 16, that ends in 6. 6 square is 36, that ends in 6. So the last digit is done. Now the first pair 28. Close to 28 you have which square? 5 square. 5 square is 25. So 5 becomes the first digit here and here. Now the important step. 28 minus 25 is 3, right? And the second doublet is 72. So it becomes 372. Now on the left hand side I need to write double of this number. 5, the double is 10. Now select a digit here which when multiplied by the same digit should get me closest to 372. Look at this. 103 times 3 is 309, close to 372. But if I take 104 times 4, it will exceed 372. I don't want to do that. Okay. So 3, and this 3 becomes the middle digit of my answer. Now this should take around 15 seconds or preferably 10 seconds for you to list down these two numbers. And after that, the digit sum method, if it works, you will have the answer. If it doesn't work, you will have to do the square of the middle number. Okay. I prefer doing the square of the middle number because I am very good in the vertical and crosswise method of finding the any square which is ending in 5. Okay. Right. So the digit sum method. I'll do both the methods here because I want you to understand what am I doing here. Let's do the digit sum of 2, 8, 7, 2, 9, 6. I can cancel the 9s. I told you 9s means 0. So 7 and 2, 9. And then 6 plus 8, 14 plus 2, 16. Right? So 16 means 1 plus 6, 7. So the digit sum of this number is 7. Now let's check 534 square. 5 plus 4, 9. I can cancel that. 3 square is 9. Oh, I got a different digit sum. So 334 cannot be the 534 rather cannot be the answer. And so my answer should be 536. Job done. But let's verify. 536 square. What do I get here? 6 and 3, 9 cancels out. 5 square is 25 and 25 means 2 plus 5, 7. Here we have the same digit sum. So 536 becomes the square root of 287296. Will you be able to do that in 30 seconds now? Still no? Let's not worry about that. Let's have some more questions and I'll leave you in this video only when you tell, okay, 30 seconds, that's it. I can find the square root. Okay? Let's develop that tendency, friends. Here we have 168921. 168921. So 1, 2, 3 odd. 1, 2, 3. Ending in 1. So ending in 1 itself, 1 square is 1. 9 square is 81. Ends in 1. 16 is greater than or equal to 4 square. So 4 becomes the first digit. It can be equal also, mind you. We can get either very close to 16 or 16 itself. So 4. And then we have the middle digit. 16 here minus 4 square 16 is 0. And then we have the second doublet 89. Right? And now on the left double of 4 is 8. So very easy. We have 89 here. So 81 times 1 will get me closest to 89. So 1 becomes the middle digit. And we have two options, 411 or 490. So let's check the digit sum of 168921. What is the digit sum? 9 gone, 8 plus 1, 9 gone, 1 plus 6, 7 plus 2, 9. 9 only, right? So let's check 411 square. 411 is 6. So 6 square. 6 square is 36. And 36 is 3 plus 6, 9. Oh wow, I got the same answer. But let's check 419 also. 419 square. 9 cancels out. 4 plus 1, 5. So 5 square. 5 square is 25. 25 is 2 plus 5, 7. And so the digit sum tallies with 411. So your answer for the question is 411. So I did this uninterrupted now so that you can understand, that this is not difficult. This is now getting simpler. And that is why watching the entire video is important. I'll give you 3 DIY questions also, do it yourself questions at the end of this video, okay? So you can post it in your comments and let me know whether you were able to do that in 30 seconds or not. Let's take one more question, a big number there, 772641. So 1 pair, 2 pair, 3 pairs, 1, 2, 3 or 1, 2, 3. Ending in 1 again, so 1 and 9. 77 is close to 8 square. 8 square is 64, 9 square is 81, right? So 8. 8 comes here, 8 comes here. 77 minus 64. See, 77 minus 64 is 13. So 13, the second pair is 26. And what do we write on the left side? We write double of this, which is 16. And now I have to choose which number multiplied by the same thing gets me closest to 1326. So let's check. 1, 6, what? 16, 5s are 80. Maybe 7, let's check 7. 7 7s are 49, 9 4, 7 6 are 42, 46, 6 4, 7 11. 1 1 6 9. Very close indeed. 1 1 6 9. But let me be sure, 168 into 8 isn't working. 8 8 is 64, 4 6, 8 6 are 48, 54, 4 5 and 8 1s are 8 plus 5 13. 13 44 exceeds. So 7, that becomes the middle digit of my answer. So either 871 or 879 is my answer. Again, the digit sum. Okay. So let's start with 772641. Then we will do 871 square and then we will do 879 square. Okay. So where are the 9s? I can cancel out the 9s, right? 7 and 2 9. There is no other 9 pair. So 7 plus 6 13. 13 plus 5 18. So 18 means 1 plus 8 9. Here we have 8 and 1 cancelling out. That forms a 9. 7 square is 49. 49 is 9 cancels out 4. Right? So 871 cannot be my answer. So should be 879. Job done. But I need to check whether this is correct or not. So 9 cancels out. 8 plus 7 15. So 15 square. 5 plus 1 6. So 6 square. 6 square is 36. 36 is 3 plus 6 9. And there it goes. It tallies with 9. So friends, I did 879 just to make you understand that the method of digit sum works, and if it doesn't work, you have to go for vertically and crosswise, okay? And I told you how vertically and crosswise works. 871 and 879, it has 875 in the middle. So you need to square 875 using Vedic maths and compare your number with the number in the middle, okay? So friends, here comes the DIY questions. Where are the questions which you have to attempt? Look at these questions. Here we have 168921. So you need to tell me what is the square root of 168921. And you need to tell me, oh, I have the same number here, so I need to just cancel this out and give you a fresh number. Wait. Okay, so you can do 1, 2, 5, 3, 1, 6 and let me know in the comments whether you got answers of these 3 questions or not. So friends, if you have learned something new, do share this video with all your friends. Do subscribe the channel and click the bell shaped icon for getting all the notifications. I hope you are enjoying all these things. Watch out for my next video in which I am going to tell you 7-digit square roots, and that will be amazing. An extension of this video and I'm sure you are going to love it. So friends, all the best for practice of 6-digit perfect square numbers, square roots, and I'm sure this is going to help you a great deal in cracking all the exams. Thanks for watching, and God bless you all. A big thumbs up for your practice.